Good morning. Myself Prabha Ramjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is representation of numbers from Unit 4, that is finite word length effect. In subject is digital signal processing. Let us discuss. Next is first of all the fundamental operations in various computational procedure like convolution, spectral estimation in DSP are multiplication and addition. These operations are performed using samples of input sequence and impulse response and the coefficient of the difference equation governing the system. The informations are numbers used for computation are called input data and the result of computation are called output data. These both input and output data are stored in registers in digital systems. The registers are the basic storage device in a digital system. The maximum size of the binary information that can be stored in a register is called register word length. The register used to store the result is 8-bit. Then the result has to be truncated or rounded accommodate in the register. This make the system is non-linear. This leads to limit cycle behavior. The effect of truncation or rounding can be represented in terms of an additive error signal, which is called as round of noise. The effect due to finite precision representation of numbers in a digital systems are commonly referred to as finite word length effect. And then because of this the following finite word length effect in digital filters will occur. First one is error due to quantization of input data by A to D converter, and then errors due to quantization of filter coefficient, error due to rounding the product in multiplication, error due to overflow in addition, and limit cycles. Let me see binary codes, the representation of the number in digital systems. Binary codes are framed using the numerical symbols like zeros and ones. Each digit of the binary code is called bit. The size of the binary code is specified in terms of number of bits. In digital system, the binary codes are used to represent any information like text, image, and numbers, etc. When decimal numbers are represented in binary code, the size of the code will decide the range of number that can be represented in binary. There are two types of representation. First one is fixed point representation and floating point representation. In fixed point representation, further there are three types. First one is sign magnitude and ones complement and twos complement representation. Mm, we see the sign magnitude fixed point representation of particular numbers. The positive number we can represent it as by 0. Next d1 d2 is the position of the bit. This is the formula for the positive number, which means n, capital N equal to 0 into 2 power 0 plus summation I equal to 1 to b di 2 power minus I. And next is sign magnitude format for negative number is negative number which is represented by 1. Remaining is same, 1 into 2 power 0 plus digit position of the digits. Then the range of decimal fraction number is minus 1 minus 2 power minus b. B is nothing but the bit, minus 1 to plus 1 minus 2 power minus b minus 1 with step size is 1 divided by 2 power b minus 1. Yeah, let me do one small activity. Here you can see a three add three chicken which is equal to 60, and add one chicken and two plate of egg which is equal to 26. Add one plate of egg and two plate of chicken equal to 15, and find the value of add one chicken and one plate of egg, and result is multiple with group of banana. The answer, command me the answer. Then we will continue the next slide, continue our lecture. Okay, next is ones complement format. The positive number is same all the format which is equal to which is represented by 0 which means 0. The format is 0 into 2 power 0 plus position of the bit. This is the formula for positive number in ones complement, and negative number which is represented by 1 remaining is same. And two's complement format is first you have to do decimal to binary conversion, then you have to take ones complement, then add 1 to the LSB of result of ones complement. This is the two's complement steps. This is the formula for a negative number. Here also positive number represented by 0 and negative number represented by 1. And two's complement range and its step size here already we have seen. And floating point representation is Mandisa plus 2 power exponent. Total size of the floating point is 8 bit. In that 8 bit, the 5 bit for Mandisa and 3 bit for exponential. Both first bit of both Mandisa and exponent represented in sign bit. Yeah, let me see the assessment of this lecture. First question for assessment is define register word length. Next one is what is mean by round of noise, and summarize the finite word length effect, and how to represent any number in radix number systems. List out the two method of representing binary number. Mention the three different format of representing negative binary fraction number. Define floating point representation. You answer me through the comment. And if you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.